All right, guys, tonight's notes are going to be the last new notes before the test, which is Friday. So the first three, A, B, and C, I'm going to do here, and then D, you're actually going to watch in another video that I'm just going to link on Classroom. I'm not going to be linking it on Edpuzzle, so I won't be checking to see that you watched it, but you do need to watch it because D is really the key example here, but we have to build to that first. So we're going to be able to solve equations that involve radicals and fractional exponents. And we're going to know how to test for extraneous solutions, which are really unique situations that you need to understand when you need to test for them. And that's where D is going to come in. So you're going to have to make sure you watch that video that I link on Edpuzzle. So for A is a pretty basic problem here. We have to simplify this. We'll have x to the 1/3 power to the 3rd power. And remember, when I raise a power to a power, what I'm doing is multiplying these two things. So I have x to the 1/3 times 3 power. 3 times 1/3 is 3/3, which is just x to the 1st. So I know that's a really basic example, but the key here is me getting you to realize that if I have x to the 1/a power, and I raise it to the a power, then I'm just going to have x. And that's a really useful thing to remember as we move forward with these equations that are involving these radicals, which are the same as fractional exponents. So for example, B, let's utilize that tool we just discovered. We want to solve this equation, so we're going to start off by doing what we would always do. I'll just move this 4 over to the other side. And I want to isolate the radical. I want the radical to be the only thing on this side of the equation. Now that that's the only thing over here, I want to get rid of the radical. So I know that a lot of you guys know how to do that immediately. And you're probably just saying it'd be very easy to do that one thing right now. But what I want you to do is rewrite this, at least for now, you don't have to always do this, as x plus 2 to the 1/2, because that's going to remind me that this scenario is the same as what we're dealing with over here. Because this was really a cubed root of x, right? But we raise it to the 1/3 power. Over here we still have just 3. If I can rewrite this like that, then I'll remind myself that the way to get rid of this radical would be to square it. Because if I square x plus 2 to the 1/2, I'll get a 1 here. 1/2 times 2 is 1. And I'm just left with x plus 2 to the 1st power. Right? That works just the same way as this previous example, as this, what I wrote here in A. If I have x to the 1/a power and then I raise it to the a power, I've unlocked this thing because 1/a times a is 1. And that's what x is. X is really just to the 1st power here. So now that I've managed to get rid of that radical, I can solve by just minus 2, x equals 7. Done. So the key is to getting rid of this radical is to recognizing that the square root of x plus 2 is the same as x plus 2 to the 1/2. And to get rid of that, we can square it. We just have to remember that we have to square both sides. All right? So the note that I might make for B here, I might say that in this situation, where we have x to the 1/a equals, I'll just put a number just to make it easier for us. To get rid of that 1/a, raise everything to the a power. And that will make things easier because then you'll be left with x equals 2 to the a. And now x is by itself, right? So that's the key, is recognizing that radicals are really just fractional exponents, and so there's a very easy way to get rid of them. C takes it the next step, because in the previous example, I'm sure a lot of you were saying, oh, I could just square this. Excuse me. The square root of x plus 2, I could just square it. Right, and this is why you could square it. And the reason I don't want you to just square it without thinking about why that works is because in this example, we have to know what to raise this to. So before I do anything, I'm going to make sure that I write this as 4b plus 29 to the 1/14th power. And on the other side, I've got the square root of -1, which looks pretty ominous, but we remember that that's really just I. So make sure to make that substitution, otherwise your life is going to become difficult. Now to get rid of that 1/14th, the power that I need to raise everything to is going to be 14. I just have to make sure that I do that on this side as well. Raise I to the 14th power. So now, 1/14 times 14, those things are going to cancel. I'm just going to be left with 4b plus 29 over here, because now that's just being raised to the first power. I to the 14th, if we remember our I cycle, is just -1. So now we've got to solve. We can finish by subtracting 29. Now I'm left with 4b equals -30, and then I have to divide by 4. b equals -15 over 2. Can't do anything else about that right now, so there it is. So a couple different skills being utilized here. We've got our I cycle coming into play. You had to recognize that we're not squaring this to get rid of that 14. Now we have to raise it to the 14th, so you're starting to recognize a pattern on what exactly it is we need to raise these to get rid of those radicals. And after that, you're really just simplifying the way you've been simplifying equations and solving equations since you were in Algebra 1. So now the last problem, like I said, I'm not going to do it in this video. I'm going to be linking a video that is through Khan Academy. This example is another guy, Sal from Khan Academy. He's going to walk you through this. It's a very unique example. You do need to watch it and then come in tomorrow ready to go for some practice on all this stuff, all right? Hopefully you guys got this and you're ready to go tomorrow. So good luck. See you guys tomorrow.